Hello, my dear students. This is Dr. Mohga, and today we're going to be talking about stars and the universe. In this lesson, we're going to talk about the composition of our star, where it's located, and the universe around it. Our star is a yellow star, which is classified as a medium-sized star known as a G-type main sequence. Its diameter is 1.39 million kilometers, made of 74% hydrogen, 24% helium, and the other 2% are other elements including oxygen, carbon, and iron. The sun's energy is mostly made of hydrogen fusing with another hydrogen to form helium. So this is known as nuclear fusion. The energy coming out from nuclear fusion is radiated as electromagnetic radiation, which is given out as infrared, which is felt as heat, visible light, which is the light we see, and ultraviolet, which is absorbed by Earth's atmosphere but can cause sunburn. Of course, all other radiations from the electromagnetic radiation are emitted out from the sun, but those three are the most that we use on Earth. Here's an example. Which of the following statements about the sun is correct? The sun is a large star composed mainly of oxygen and nitrogen. The sun is a medium-sized star made mostly of hydrogen and helium. The sun generates energy through nuclear fission of helium into hydrogen. Or the sun only emits energy in the visible part of the electromagnetic spectrum. The correct answer is the sun is a medium-sized star made mostly of hydrogen and helium. Next, let's talk about how stars produce energy. As we've discussed earlier, hydrogen nuclei, which is protons, hydrogen, it has 1 as its atomic number. So when this hydrogen fuses with another hydrogen, they form a helium nuclei. This process releases a lot of energy in the form of light and heat due to the mass difference being converted into energy as per Einstein. Now, our star is a stable star. And it's stable because its inward gravitational force, keeping all the planets and other objects in our galaxy in place, is equal to its outward radiation pressure due to nuclear fusion, making it a stable star. Now, the fusion of hydrogen occurs by a process known as proton-proton chain reaction. Why do we say proton-proton? Because of the hydrogen-hydrogen fusion. All right, here's an example. Explain how energy is produced in a stable star like the sun. Include type of nuclear reaction and the elements involved. We're going to say the same thing, that energy in stable stars is produced by nuclear fusion, where the hydrogen nuclei or protons fuse to form helium nuclei in a reaction known as proton-proton chain, which releases a large amount of energy because some of the mass is converted into energy as described by Einstein's equation E = mc squared, where the outward pressure from this energy balances the inward pull of gravity, keeping the star stable. Now let's talk about the galaxies and the astronomical distances. Here we have 3 definitions to consider. First of all, what's a galaxy? A galaxy is a vast collection of stars, dust, gas, and dark matter, held together by gravity. Our planet is in a galaxy known as the Milky Way. Of course, there are other galaxies such as the Andromeda Galaxy, the Triangulum Galaxy, and many others. So, the second definition we need to know, what is a Milky Way? The Milky Way is a spiral galaxy where the Sun is located in one of its outer spiral arms known as the Orion Arm, which is 27,000 light years from the galactic center. The third definition we need to know is, what is a light year? Light year is the distance that light travels in vacuum in 1 year. So, for instance, the Sun is almost 150 million kilometers from Earth, making it the nearest star to us. And all other stars in the Milky Way are much further, making them thousands or so many light years away from us compared to our own sun. So the closest star system is about 4.37 light years away, where 1 light year, like we said, is equal to 9.46 times 10 to the power 15 meters. So can you imagine how far those other stars are from us? So due to their great distance, these stars appear as tiny points of light in the night sky, whereas our sun appears large and bright. Here is an example. Which of the following statements is correct? The sun is the only star in the Milky Way galaxy. All stars in the Milky Way are closer to Earth than the sun. A light year is the time light takes to travel around Earth. Or the sun is a star located within the Milky Way galaxy, and other stars in the Milky Way are much further from Earth than the sun is. Of course, the correct answer is D. Next, let's talk about the Milky Way. As we said, the Milky Way is the galaxy that contains our solar system. It's one of many billions of galaxies in the universe, where each galaxy is a massive system of stars, dust, gas, and dark matter held together by gravity. So our key facts are: number 1, the Milky Way is a spiral galaxy. Number 2, contains over 100 billion stars, including our own sun. Number 3, its diameter is approximately 100,000 light years. Number 4, solar system is located on one of the spiral arms, about 27,000 light years from the center. And finally, the universe contains billions of galaxies, each with billions of stars. So the 3 terminologies we've taken: Milky Way, galaxy, and universe. Here is an example. Light from a star located on the far side of the Milky Way takes about 100,000 years to reach Earth. What does this imply? Since the diameter of the Milky Way is 100,000 light years, it means that light from the far edge of our galaxy takes 100,000 years to reach us. So when we observe that star, we're actually seeing it as it was 100,000 years ago. Now let's talk about redshift. Redshift, when we're looking at the planets or the objects or the stars that are around us, we look at their wavelength. If their wavelength is increasing, so they're getting a longer wavelength, that means that they're shifting towards the red end of the visible spectrum. So a longer wavelength means actually that they are going away from Earth. So if I see that an object in space, its wavelength is increasing or becoming longer, this means that it is going further from Earth, and we call this a red shift. So why does redshift occur? When a star or a galaxy moves away from Earth, the light waves are stretched, increasing their wavelength, and this shift in wavelength causes the light to become redder, hence the name redshift. Just for your info, if an object is coming closer to Earth, then the wavelength will become a shorter wavelength, and we call this a blue shift. So the key concepts we've taken so far: redshift is an increase in the observed wavelength of light from objects moving away from us. Receding galaxy is a galaxy that is moving away from Earth and shows redshifted light. And an expanding universe is the idea that galaxies are moving away from each other and space itself is stretching. So this takes us to the Big Bang Theory. The observational evidence that we've seen is that light from distant galaxies is redshifted when compared to light from sources on Earth. The further away a galaxy is, the more its light is redshifted, meaning it's moving away faster, which suggests that the universe is expanding in all directions. So the fact that the galaxies are moving away from us and from each other implies that the universe was once much smaller and denser. And this is exactly what the Big Bang Theory is. It states that the universe began from a very small, hot, and dense point and has been expanding ever since. So, coming to our final example of this lesson, light from a distant galaxy is observed to have a longer wavelength than the same light emitted on Earth. What does this tell us about the galaxy's motion? This is evidence of redshift. The increased wavelength means the galaxy is moving away from us, so the redshift indicates that space between us and the galaxy is expanding. Therefore, this supports the idea that the universe itself is expanding as described by the Big Bang theory. I hope the lesson was clear. Please let me know if you have any further questions. Have a good day.